Now it's done. Just a minute. Fine. Now it's visible. Screen is visible.
Yes, sir.
Okay. Okay, fine. So we have done. I think examples, all the examples we have completed, right? How many examples we have done?
30, sir.
30.
30, yes, sir. 30.
Okay, fine. Then it's done. Fine. Now, just a minute. Write down that consider 18 electron rule. Consider 18 electron rule as a guide. Okay, as a guide. Determine the unknown quantity. Determine the unknown quantity in the following complexes. So you have to take help from your 18 electron rule. Then you have to determine like which property they are actually asking. Okay, so they have given capital M is equal to fast row transition metal. Okay, fast row transition metal. So they have given this compound. Okay, now what they are asking, actually they are asking this metal is what. Okay, the metal, which metal it is, actually they are asking that. Okay, do it. So you have to take help from your 18 electron count, 18 electron rule. So basically the valence electron should be equal to 18, right? So do it. Okay, so if you are not getting first example I am doing, so suppose I am considering neutral method. Okay, I am considering neutral method here. So if you consider neutral method, so from this cyclopentadienyl ring, how many electrons you will get? 5 electrons, right? Metal, how many electrons metal is donating, that we do not know, so I am writing as M, or you can write down as X, whatever. And from cyclopentadienyl you will get how many electrons? If you are considering neutral, how many electrons you will get from this cyclopentadienyl ring? Sorry, the cyclobutadiene ring. This is what? Cyclobutadiene means how many electrons you will get? This circle means what? Circle means all the carbon atoms are actually involving in donation, right? So how many electrons you are donating? 4 electrons. Okay, see, this pi want 2 electrons, this pi want 2 electrons, total 4 electrons, that's it. So these and these are equivalent, na? this thing also I can write down like this. Okay, so this 5 electrons from this cyclopentadienyl ring, metal is donating unknown, and from this cyclobutadiene you are getting 4 electrons, so that will be equal to what, 18, right? So that means metal is donating how many electrons, 9 electrons. So metal is donating 9 electrons in neutral method. So which metal it is? First row, transition metal, they have already mentioned you. 9 electrons. What should be the electronic configuration? 3d7
Cobalt, sir.
4s2, 3d7 4s2, 9 electrons. So this is what, this is your cobalt. Clear? How to find out the metal, which metal is involving there? Clear? Tell me any doubt. Any doubt?
No, sir.
No, right? Okay, next. Okay, Sampriti Chandana, any doubt?
No, sir.
No, right? If any doubt, just stop me and ask me, okay? Find out the metal. Same thing, do it. So we have done this thing, na? Linear NO and bent NO. Can you tell me linear NO donates how many electrons?
3 electrons, sir.
3 electron. Bent NO? Bent NO? 1 electron. Right? Linear NO donates 3 electron. Bent NO donates 1 electron. What is it? Linear or bent?
Linear, sir.
Linear. So 3 electron from your this NO. Metal is unknown. From cyclopentadienyl ring you will get 5 electrons. So that will be equal to what? 18. Okay. The number of valence electron, total number of valence electron will be equal to 18, na? So that means what? Metal is equal to 10. So which metal it is?
Nickel.
Nickel. 3d8 4s2. Okay, so it will be your nickel. Clear? Write it down, then we have done this. So this thing is important, okay? Linear NO donates 3 electron, bent NO donates 1 electron. Why they are donating? That we'll take a class, okay? That we will do later. But now remember, linear NO donates 3 electron and bent NO donates only 1 electron. Okay? Okay, now next, suppose you have this. Just a minute. Join. Okay. So CO, CO, CO. Find out which metal it is. Which metal it is?
Cobalt.
What? Cobalt, how you are getting? Check. Benzene ring donates how many electrons? Benzene?
Sir, chromium, sir.
Benzene ring will donate how many electrons? See, this thing I have already told. Suppose benzene I am writing like this, na? 3 pi bonds you have. Now you have a metal present here. So this pi bond donates, this pi bond donates, this pi bond donates. Okay. If all the pi bond donating, so that thing we are writing like this. That thing we are writing like this. Make a circle and then write down like this. So that means all the pi bonds are actually donating electrons to the metal center. So you have 3 pi bonds, so that means total you will get 6 pi electrons from your benzene ring. Metal is unknown, and each CO is donating how many electrons? CO
2 electrons, sir.
2 electrons, right? So CO is donating this 2 electrons, so that means from 3 electron 3 CO you will get that. Okay, that is equal to 18. So this is 6, this is also 6, 12. So metal is equal to 6. 6 means what? 35, 4s1. Okay, chromium it is. Clear?
Yes, sir.
So this 18 electron rule is very important. Okay, this you have to understand pretty well, otherwise you will not understand the advanced organometallic chemistry, because whenever you will do the mechanism, that time this 18 electron concept you have to take, and basically whatever the ligand's nature you have to understand, how many electrons they are donating, that should be pretty much clear to your mind. Okay, otherwise you will cannot do it. Okay, so any doubt you just ask me. Find out which metal it is. Which metal? So metal is unknown. I am writing M. From you have 7 cobalt, so each cobalt donates how many electrons? 2 electrons. So 2 into 7. Now if you have a positive charge, so positive charge means what? You are releasing electron, right? So it will be -1. If you have a negative charge, that time you will add the electron. If you have positive charge, you have to subtract the electron. So -1, that is equal to 18. So what you are getting? 5, na? 19 minus 14 will be 5, right? If you are getting 5, so that means which metal? 3d3, 4 is 2. This is what? Vanadium. Clear? Clear? So I am
Yes,
going
sir.
very slowly. I am going very slowly. Okay, I am not doing any step jump. Okay, you just see. You have to determine the metal, right? So metal I am just, you can consider M or you can consider X also. That is not a factor. So just M plus how many electrons CO is donating. Each CO is donating 2 electrons, right? So CO is donating 2 electrons. So you have 7 CO. So 2 into 7. You have a positive charge. So that means what? You have to subtract. Okay, if you have a negative charge, you have to add. If you have a positive charge, you have to subtract. So -1, that is equal to 18. So metal is equal to 5, so that means what? 3d3, 4 is 2, right? So that will be your vanadium. Okay, now suppose you have this metal. Find out the metal, which metal it is. So tell me how to calculate.
Is it chromium, sir?
Which one you are getting?
Chromium.
Chromium, yeah, chromium, correct, chromium. So for CO, I will get how many? 5 into 2, right? 5 into 2 I am getting for carbonyl. Metal I am assuming as M, okay? And if you have a double bond, so what? I am considering neutral method, right? Neutral method means what? What? Homolytic or heterolytic? Homolytic, right? Homolytic cleavage. So that means how many electrons you are getting from this double bond? 2 electrons. So that is equal to 18. Neutral method, always consider neutral method, that will be easy. Okay, so 10 plus 12, so metal is equal to 6. Okay, so again it will be what? 3d5, 4s1, which is equal to what? Chromium. Okay, which is equal to your chromium. Okay, so if you have double bond, so that will donate 2 electron. If you have triple bond, that will donate 3 electron, because you are considering neutral method. Okay, write it down. Done.
Yes, sir.
Done. Cobalt, CO, whole 3 and whole Z. Okay, one thing I actually forgot to discuss actually. So basically recently NTA has changed the exam pattern for your NET exam. Okay, they have totally changed the exam pattern for your NET exam. That I will discuss separately. Okay, I will make a video for that and then I will upload what are the changes they have made. So basically what is the major change they have done? Initially in part C we have 60 questions. Apart from among the 60 questions we have to do only 25 questions correctly, right? What they have done, this part C they have made like GATE exam, they have made it MSQ portion. Sorry, like GATE exam they are making it your MSQ. Okay, sorry, MSQ portion. So MSQ questions will be there in your part C, and from that, so basically if you make it right, you will get 5 marks. Okay, you will get 5 marks, but if you make it wrong, you will get 0 marks. No negative marking is there, but the thing is, yeah, MSQ will be there, MSQ questions. Okay, and for part A and part B I will update. Okay, there will be negative marking definitely. For part C there will be no negative marking, but yeah, the thing is this will be now MSQ. If suppose 3 answers are correct, you are doing two options similar to your GATE and IIT JAM exam, you will not get any marks for that. There is no partial marking. MSQ means properly you have to mention that much options, then only you will get 5 marks. Okay, so I can say that is the advantage as well as it is a disadvantage also. So yeah, that is the change they have made. Okay, so no need to think about that. So what I can say, whatever you are doing, so your concept should be clear. Okay, otherwise that MSQ portion will be tough. Okay, your concept should be clear, otherwise you cannot do it correctly. Okay, fine. So here they have mentioned the metal. Here you have to find out the J value. Okay, J value is what? Find it out.
Sir, -3.
Correct. How you are getting -3?
Sir, that CO will get 6 electron.
CO. Okay, no. How you are actually getting -3?
Sir, cobalt, sir. If you have the total electron will be 15. If you have -3 means
Okay,
we have to add +3.
9 electron from your cobalt, 3d7
Yes, sir.
4s2, right? 9 electron
Yes,
from
sir.
your cobalt and 6 electron from your carbonyl group, right?
Yes, sir.
Now what you are doing?
Sir, -3, sir. If there is minus charge means we have to add +3.
Correct. So here don't do like this. Suppose plus z is equal to 18, right? So if you do like this, so see what you will get. Z value is equal to what you are getting? 18 minus 15, right? You will get 3. So if you have cobalt in plus 3 oxidation state, no, sorry, yeah, correct, right? Yeah, if you have plus 3, suppose this is charge is your plus 3, so how many electrons you are getting? 9 from your cobalt. Now calculate, suppose you are getting this Z value your plus 3. Now calculate. So 9 electrons from your cobalt, 6 electrons from this carbonyl, 15 and plus 3 means what? You have to subtract. Okay, not to add, you have to subtract. So that means you will get 12 electrons. So this Z value will be your -3, not +3. If you do it -3, so that means what? 9 electrons from your cobalt center, 6 electrons from your carbonyl, and -3 will be the charge. Then only you can add and you will get 18. Okay, so that's why it is important. Okay, you have to check, cross check, you just do this. Okay, if you make it +3, then it will be 12 electrons. If you make it -3, then only it will get this 18 electrons. Okay, clear? Clear?
Yes, sir. Yes, sir.
Okay, fine, good. Now try this one. Ruthenium CO whole 4. Then you have here SiMe3. SiMe3 whole to the power Z. So again find out the Z value. Okay, first of all tell me SiMe3 donates how many electrons? This ligand will donate how many electrons?
0 electron.
0 electron. Check. SiMe3. What is the valency of silicon? How many? What is the valency?
4, sir.
4, right?
It
So,
donate 1 electron, sir.
So Me3 means what? Me3 means, okay, I am understanding like this. Suppose silicon has initially 4 electrons. 1, 2, 3, 4. Now organic you know, right? So methyl means what? CH3. So this is also your carbon center, right? One electron left. If I show you, so this is basically your bonding chapter concept, huh? CH3 means what? You have 3 carbon hydrogen bond. This is your CH3. So carbon has also 4 electrons, so that means 1 electron left, right? Now this electron and this electron, they are making covalent bond. Similarly, if you have another CH3 unit, that will also have one odd electron. So this electron and this electron, they will make a bond. Again you have CH3, so that will also have an odd electron. So this electron and this electron, they will make a covalent bond. So ultimately what we are getting? Si. Here you have methyl group, here you have methyl group, here you have methyl group, but this electron left. So that one electron it will donate. So it will donate only one electron. Clear how to check?
Yes, sir.
Okay, now calculate it. Tell me the Z value, what you are getting.
-1, sir.
-1, right? So ruthenium will donate how many electrons?
8 electrons,
8
sir.
electrons from ruthenium center. Good. Iron, osmium, ruthenium, so 8 electrons. And carbonyl, so you have 4 carbonyl, so that means what? 2 into 4, 8 electrons from this carbonyl, 1 electron from your SiMe3 unit. And now again Z value you consider plus Z is equal to what? 18. So what you are getting? Check. Z is equal to 8 plus 8, 16, 17. So you should get 1. Z is equal to 1. Again it will be wrong. So you need to cross check. If you make it plus 1 here, if you are making it plus 1, so already how many electrons you are getting? 8 electrons from here, 8 electrons from here, and 1 electron from here. And if you have plus charge, positive charge, so that means you have to subtract. So you are getting 16 electron, right? But if you have here minus charge, if you have minus charge here, so that time you will add another electron, and ultimately you will get 18 electron. Okay, so Z value will be -1, not +1. Clear? Clear? Better you can write down like this. Just write down 8 plus 8. First of all, check how many electrons they are donating individually. Then check, make it a Z value, take plus minus both the value you just take, and then check where you are getting 18. Okay, how you are getting 18. Okay, done.
Yes, sir.
See, organometallic is interesting, okay, but it is similar to your organic chemistry, okay. Now when you will do research, that time you will see organic people also do organometallic chemistry, okay. So this concept is you know actually, okay. And now you will do MSc, or yeah, whoever done MSc, for them it's fine, okay. But if you want to see more example on this 18 electron rule, okay, or you want to understand the mechanism, so there is a very standard book for your organometallic chemistry, that is known as your Crabtree, okay. Crabtree, this is the very famous book for organometallic chemistry. In library you will get, okay. So just pick from there if you are interested, okay. Otherwise you can follow the notes, okay. Some examples I have taken from there, some examples I have taken from other book also, okay. But Craft is the standard book you should follow, okay. Fine, now do this one. Find out the Z value. Okay, I have a general question. First of all, tell me, this alkyne will act as a terminal ligand or bridging ligand here? Tell me. In interview they will ask you basic questions, okay, they will not ask you any difficulty question. So suppose I am asking that in this alkyne it will act as a bridging ligand or terminal ligand.
Terminal.
Terminal. Why terminal?
Only
One metal is present, okay, so that is a very easy thing, okay, common sense, okay, so you just use your common sense. Only one metal we have, so that will act as a terminal ligand. Now next thing, if it is acting as a terminal ligand, so how many electrons it can donate?
1 electron.
1 electron. How? It will donate 1 electron. This is the ligand you have: pH, carbon, triple bond, hydrogen. So is it possible for this ligand to make a sigma bond with the metal center?
No, sir.
Then which electron it will donate? Pi electron, right?
Yes, sir.
These electrons are available, na? Already this carbon has 4 valency, so sigma bond is not available, na? See, the valence is already fulfilled. 3 electrons here, 1 electron here, 3 electrons here, 1 electron here. So no sigma electron left. So it will donate its pi electrons. When it donates the pi electrons, if it is donating to only one metal center, so that means one pi bond donates. So that will be 2 electron. If it is donating both the pi bonds to other metal center, then it is acting as a bridging ligand. So keep in mind, if you have alkyne compound, so if it is acting as a terminal ligand, these are the small things, but these are important from your basic understanding, okay. Terminal ligand, so that will donate 2 electron, okay. If it is acting as a bridging ligand, so that means more than one metal center is involving there, so it will donate 4 electron. Clear? Now do it. Now it will be easy. +2. Check. All of you are getting +2?
+1.
+1. Okay, what about 9? Cyclopentyl is donating 5 electrons, neutral method, right? CO will donate how many electrons? 2 CO, so 4 electrons. Iron will donate how many electrons? 8 electrons. And this one is acting as a terminal, so that will donate 2 electrons. Now check how many you are getting. 5, 4, 9 plus 8, 17 plus 2, 19. So you are getting already what? 19 electron, right? 19 electrons. So this Z value should be what? If you are making +2, so that means what? -2 electron, right? So you will get 17. So you have to do what? 19 minus 1. So that will be 18. So that means the Z value will be here +1. Okay. Clear? So be careful, okay. This kind of things you no need to hurry. You just take time, but make it correct, okay. Because here the concept of bonding actually requires, okay, and this bridging you have to identify, like it will act as what, okay. Clear? Done?
Yes, sir.
Okay. Now next I have this example. Find out the n value. Easy, okay. This one is very easy. Do it correctly.
Sir, 5, sir.
What you are getting? 5, right? Okay.
Yes, sir.
So manganese will donate how many electrons? 7. Okay, now the question is bromine will donate how many electrons? So how many electrons bromine has? 2, 4, 6, 7. So now check which bond it is forming with manganese, sigma bond, right? So if it is forming sigma bond, so that means what? It will donate 1 electron, manganese will donate 1 electron. Okay. So for bromine center you will get 1 electron, and CO is donating 2 electrons, that we know. We have n number of CO, so that will be n into 2 is equal to what? 18. So what we are getting? 2n is equal to 10 and n is equal to what? 5. So you have 5 CO here. Clear?
Sir, in previous question,
Hmm.
you have not mentioned the eta value for CP, sir.
If it is donating 5 electrons, then it will be eta 5. Okay.
Sir, if it not mentioned means how can we say that it will
Then you
donate
have
5
to
electrons?
consider 5. If
Okay, sir.
not mentioned, so that means all the bonds are already involving there. Okay.
Yes, sir.
If not mentioning anything, so that means all the atoms are involving. Okay. If they are mentioning specifically eta 1, eta 3, that time you just consider according to that. Okay. Okay, fine. Okay, good. Like that you have to actually ask questions, huh? Because if you ask questions, then only it will be clear. Suppose here I am writing eta 5, C5, H5. So this is also Cp. Okay. Then you have cobalt. Then you just write down CnHn. This example I will do. No need to worry. So this is the thing. Okay. Now basically, if you see, from this cyclopentadienyl you will get 5 electrons. From cobalt you will get 9 electrons, and that we do not know. From CnHn we do not know how many electrons we will get, so I am assuming x. So 5 plus 9 plus x is equal to what? 18. So x value will be what? 4, right? So that means the CnHn unit is donating 4 electrons. Okay, CnHn unit is actually donating 4 electrons. Okay, now there could have many units like that. So first of all, write down that if n is equal to 1, suppose this n value I am considering 1, so that time what I will write down? CH, right? If I consider n value is equal to 1, then it is becoming CH. So now can you tell me how many electrons CH ligand is donating? CH ligand will donate how many electrons? Difficult? Carbon has 4 electrons, right? Carbon has
Electrons.
4 valency. Already it is making one bond with hydrogen. So that is your CH. How many electrons left? 1, 2, 3. So it will donate 3 electron. Clear? How to check? First of all, draw and fill the octet. You have to fill the octet here. So carbon has 4 valence electrons. Already it is making a bond with hydrogen. So that is your CH unit. How many electrons left? 1, 2, 3. 3 electrons left. So that is what? That is your CH. So CH can donate 3 electrons. So if it is donating 3 electrons, so that means this ligand is not CH. Okay, this cannot be CH because it is donating 3 electrons. We are getting 4. Okay, it is donating 4 electrons. Clear? Tell me any doubt.
No, sir. Clear, sir.
Sampriti, Chandana, clear? Any doubt?
Yes, sir.
Clear. Now consider n is equal to 2. Then what you will get? What I have to write down? C2H2. C2H2 means what? C2H2 means which molecule it is? Hmm? Acetylene, na? C2H2 means what? Acetylene molecule, na? Okay. So now the thing is, see, only one carbon, only one metal center is there, so that means definitely this triple bond is acting as a terminal ligand. So how many electrons it is donating? C2H2. How many electrons?
2 electrons.
2 electrons. So again it is not your C2H2 unit. The CnHn is not your C2H2 unit. Okay. Now next come n is equal to 3. So if I make n is equal to 3, so that will become what? C3H3. Okay, C3H3. Now basically how can you can ask me, so how can I get C3H3? So suppose you have this kind of allyl system. Suppose with this carbon metal is attaching. Now check. So this carbon you have 2 hydrogen, this carbon you have 1 hydrogen. Okay. No, sorry, this will not be. This is not your C3H3. C3H3 means you have to make it cyclic, then it will be. If I make it cyclic, three carbons you have, so first of all make 3 carbons like that, then make a double bond here. So how many hydrogen left? Here 1 hydrogen, here 1 hydrogen, and this carbon center is attaching with your metal center, so that means 1 hydrogen left. So this is your C3H3, right? Clear? 3 carbons you have, 3 hydrogen you have, and this carbon center is attaching with your metal center, so C3H3 is the ligand unit. Okay, so how many electrons it is donating? So first of all it has 2 binding modes. It can donate as eta 1, it can donate as your eta 3. If it is donating as eta 1, so that means what? Only this covalent bond I have to consider, this bond, so that time it will donate only 1 electron. And if it is acting as eta 3, so that means this pi bond is also donating electrons to the metal center. So 1 electron is getting from this single bond and 2 electrons from this pi bond. Overall it is donating 3 electrons. So again it is not able to donate 4 electrons, so this is also not possible. C3H3 is also not possible. Is it clear?
Yes, sir.
Clear. So next option is what? N is equal to 4. N is equal to 4, so that means what? C4H4. Can you tell me what will be the structure of C4H4? So first of all draw all the 4 carbon atoms. You can make it linear also, but you know already if you make it linear you will not get this C4H4. So make it a cyclic, then give double bond to here. Okay, so now check how many hydrogens you have. 1, 2, 3, 4. Okay, now suppose you have a metal center here, so this pi bond donates as well as this pi bond donates. So how many electrons it is donating?
4, sir.
4 electron, so that is the answer. Okay, so that CnHn unit is basically your what? C4H, the cyclobutadiene moiety. Okay, this cyclobutadiene moiety. I can also consider n is equal to 5, so that means what? C5H5. So C5H5, you know what is C5H5? Cyclopentadienyl. This is your C5H5. So there it will donate, it can donate actually 1 electron, 3 electron, 5 electron. If eta 1, that time 1 electron. If eta 3, 3 electron. If eta 5, then it will donate 5 electron, but not 4 electron. So again n is equal to 5 is not possible, so only one option we have, that is n is equal to 4. Cyclobutadiene, it will be the moiety, or it will be the ligand. Clear? Any doubt? Clear? Any doubt? Okay, see. So initially we have this molecule C5H5 cyclopentadienyl. It is donating 5 electrons. Cobalt is neutral. Consider neutral method, so it will donate 9 electrons. CnHn we do not know, so we are considering that it is donating X electrons. So X value what we are getting? X value we are getting 4. So now we are checking one by one. So if n value is 1, so that is CH. If you are getting CH, so that means it has 3 odd electrons available to donate, so it will donate 3 electrons, which is not possible. If n is equal to 2, so we are getting C2H2. C2H2 means what? Acetylene molecule. So again it's a terminal ligand, because only one metal center is present here. So if it is a terminal ligand, it will donate one of the pi bond, and it will again donate how many electrons? 2 electrons, but not 4 electrons. So it is also not possible. In C3H3, it is also donating how many electrons? 3 electrons. So this is also not possible. C4H4, it is donating 4 electrons, possible. C5H5, it is also donating 5 electrons, so this is also not possible. Clear? Clear?
Yes.
Any doubt? Tell me any doubt. Shall I proceed?
Yes, sir.
Okay. Okay, so they are actually asking here x and y value. C6H6, you know what is C6H6. They just are asking what is the x and y value it can be. It can differ, but yeah, tell me at least one value. You can do it, okay? Do it.
Sir, X can be 6 and Y can be 4, sir.
6 and 4, yeah, good. So basically, first of all, ruthenium is donating 8 electrons, right? Ruthenium is donating 8 electrons. Now suppose I am considering that this is donating X electrons, so X plus 8, and this is donating Y electrons. So X plus 8 plus Y is equal to what? 18. So basically what? X plus Y is equal to 10. Now you know what is C6H6. What is C6H6? Benzene, na? You have two benzene rings, right? So now the sum of their donation will be 10. Now it cannot be like that 8 plus 2, right? Because you have maximum 3 bonds, so maximum 6 electrons it can donate. So just consider that it is donating 6 electrons. So if you are considering 6 electrons, one benzene ring is donating 6 electrons, so automatically the other value will be what? 6 plus 4. Automatically it will donate 4 electrons. Okay, now x value can be 6, y value can be 4, or you can say sir x value is 4, y value is 6. That is also correct. Okay, but ultimately one benzene ring will donate 6 electron and the other benzene ring will donate 4 electrons. So basically the structure will be like this. So you can show like this. Ruthenium, and here you have 1 2 3 4 5 6. So here I have a single bond, and here the double bonds is in conjugation. Okay, so they are donating electrons also, like that. Okay, so you can show like that. Clear? that will be the structure. Okay, clear?
Yes, sir.
Okay. Now next, suppose you have eta x Cp2 tungsten CO whole 2. Find out eta value, this eta to the power x value. Okay, so basically Cp2, huh? So you can consider like this. This is whole 2. Okay, this is whole 2.
Sir, is it 4?
What you are getting? Yeah, 4, 4. Correct. X value, na? You are saying this value, na?
Yes,
Uh,
sir.
this value will be 4, correct. So basically, suppose it is donating x electron, so you have 2 units of that, so that will be 2x. Fine. Now tungsten, so tungsten means what? 6 electrons. CO will be how many electrons? 4 electrons is equal to what? 18. So 6 plus 4, 10. So that means what? 2x is equal to what? 2x is equal to 8, right? So x is equal to 4. Okay, so x is equal to 4, but basically if you see the structure of your cyclopentadienyl, cyclopentadienyl, so now tell me how you have two cyclopentadienyl units. So I am drawing like this. Okay, I am drawing like this, and suppose in the middle you have this tungsten. This kind of compound actually known as your sandwich compound. Okay, sandwich compound, because the metal center is sandwiched between the two rings. Okay, so now tell me, for one system is it possible to donate 4 electron for one cyclopentadienyl?
No, sir.
Already it is forming one bond. Okay, this covalent bond, this sigma bond, you cannot deny. Okay, that you cannot deny, already it is forming one bond. So 4 is actually, because your calculation is correct, x value is 4. Okay, but you have to think now from the molecule point of view, that already this ligand, first of all I told one thing, that whatever the bridging ligand you have, that is what, first of all it will form a sigma bond. Okay, sigma bond formation is must. Without sigma bond, without forming sigma bond, you cannot form pi bond. In organic chemistry it is also same, right? If you get some unsaturated compound, so the first thing is sigma bond. Sigma bond you have to form. Without sigma bond you cannot form pi bond, right? So here also the thing is same. Okay, if you see the structure of this molecule, this value what you are finding out, that is absolutely correct, but that you have to understand from the molecular point of view also. Okay, what is your molecule? So So you have cyclopentadienyl ring, so that is already making a sigma bond with your metal center. Okay, you can choose any ligand that will make a sigma bond, definitely. Suppose you have halogen or you have carbonyl, okay, any kind of bond, they will make a sigma bond first of all. Okay, so now what are the possibilities? So already it is donating one, it is getting one electron from this side, one electron from this side. I can think like this, that okay, from both the rings it will get 8 electrons, right? That we are getting 2x is equal to 8, right? So from both the rings it will get 8 electrons. So 1 electron from this sigma bond and 1 electron from this sigma bond. Now suppose this pi bond is donating electrons to this pi bond is also donating electrons to this. So how many electrons it is getting in total? How many electrons? 5 electrons from this side. So how many electrons it should get from this side?
3.
3 electrons. So that means what? If it is getting 3 electrons, so that means what? 1 electron it is already getting, and one of the pi bond will donate the electrons to this metal center. So you can represent this structure like this also. Okay, like this. Okay, and definitely two carbonyls are attaching with this. Okay, so mathematically your answer is correct. Okay, but you have to think from the molecular point of view. Okay, that you have to do in chemistry.
Sir, here should we write separately like eta 5 and eta 3?
That I am doing na. Here all the carbon atoms are actually involving in donation, but here only three carbon atoms are donating. So basically, yeah, the modified formula will be like this: eta 5 Cp, and another one will be your eta 3 Cp, then tungsten CO whole 2. Yeah, correct. Correct. So because we have to modify it, right? Done.
Yes, sir.
Okay. Another we have eta 7 tropylium. Tropylium, you know what is tropylium? Hmm? What is tropylium? You just check here how many electrons are there. First of all, tell me what is tropylium? Okay, when we have done aromaticity, that time we have discussed tropylium. Maybe I have not written the name, but this structure, this compound you know pretty well. Okay. So this is a 7-membered ring. Okay, 1 2 3. Okay, and with this carbon metal center is attaching. So what should be the formal charge here? What will be the formal charge here? Chandana, is it aromatic or anti-aromatic? Hmm? Formal charge you forgot, formal charge?
+1.
+1. So if I break the bond like this, so that means what I will get? What I will get? So 1, 2, 3. The electrons are coming to the metal center, right? So that means here positive charge will generate, metal will get negative charge, and this is what 2, 4, 6, 6 pi electron you have. Okay, so that is becoming aromatic. So the formal charge will be +1. Here don't break the bond like this. If you are breaking like this, so that means you are making it anti-aromatic, which is not at all stable. Okay, so metal will not get here positive charge, metal will get negative charge. Why? What is the reason? Because this ligand is your aromatic system, so that will gain more stability. Clear? So now remember, tropylium means it's a 7-membered ring with a positive charge. Okay, and these 3 pi bonds are in conjugation. This is your tropylium cation. Tropylium cation, or they can say tropylium ligand also. Organic chemistry we will say tropylium cation. Okay, when you will do organometallic chemistry, that time they will say tropylium ligand. Done. And this is the formal charge +1. Okay, done.
Yes.
Done, right? Okay, fine. So it's done for us. Now next, give a heading that calculating total number of metal bonds. Okay, calculating total number of metal bonds. So suppose you have this bond, metal bond. So how many bonds are there? Only one. Suppose you have a bridging ligand this. So what will be the value for this kind of bonding? Total number of metal bonds. What will be the value here?
0, sir.
0. If you have this metal, this here also 1, right? If you have like this, because cluster compounds they basically exist will like that. So here it will be 3. Okay, 1, 2, 3. 3 metal bonds. Okay, in total you are getting 3 metal bonds. But if I ask total number of metal bonds per metal, then it will be what? They can ask you both the ways, total number, or suppose they are asking like this, total number of metal bonds, total number of metal bonds per metal. So it will be what? See, one metal is doing how many bonds? 1, 2. This metal is doing how many bonds? 1, 2. So it will be 2. Okay, so total number of metal bonds per metal, it will be equal to what? 2. Clear? Now I am writing the formula. So write down that total number of metal bonds, total number of metal bonds, which is represented by K. Okay, which is represented by K. So what is the formula we have here? 18n, okay, minus valence electron divided by 2. This formula you have to remember to find out the number of metal bonds. Now the question is, what is n? what is small n? So write down small n is equal to total number of metal atoms, total number of metal atoms in a compound, okay. And VE is equal to what? VE is equal to valence electron, so this n, small n, stands for what? Total number of metal atoms in a compound. You have to just calculate how many metal atoms are there, and valence electron, how to calculate that you know, okay. Clear? This formula is clear? Write down in square, okay. This is very important formula, okay. Done. Okay, so this is your total number of metal bonds. Another formula is there, that is your same thing, total number of metal bonds, per metal, if they are asking per metal, okay. Total number of metal bonds per metal, so that will be 18 minus valence electron divided by 2. This is another formula, okay. So both you should know. One is your total number of metal bonds, that is 18n minus valence electron by 2, and the second one, total number of metal bonds, it will be 18 minus valence electron by 2. That's it. Clear? Clear?
Yes, sir.
Done. Now let's practice some question, okay. Some examples let's do. So first of all, do this one. Suppose you have Mn2 CO whole 10. Do it. Tell me that small k value. So that means what? Total number of metal bonds. First of all, tell me that what you are getting.
One.
1, right? So 18n minus valence electron by 2. So first of all, see what is the n value. How many metals are there? 2 metals. So write down 18 into 2 minus valence electron. So manganese has how many valence electron? Calculate in neutral method. So 3d5 4s2, right? So 2 into 7 plus how many carbonyls you have? 10 carbonyls. So it will be 2 into 10. If you add, so 14 plus here 20, so that means 34. So 18 minus 2, okay, 18n minus valence electron is 34 divided by what? 2. So what you are getting? 1, right? So only one metal bond is there. So what will be the structure? So only one metal bond is there, one manganese bond is there, and each manganese will occupy 5 CO. Total you have 10 CO, so that means each manganese actually holding 5 CO. Okay. Clear? Clear? Any doubt here?
Yes, sir.
Clear? Any no doubt, right? Okay. Now find out for this Fe2CO9. Fe2CO9. Fe2CO9
One, sir.
1, right? So K is equal to how many metals are there? Again you have only 2 metals, so 18 into 2. Now find out valence electron. So iron, what is the, in neutral method, what is the electron configuration of iron? 3d6 4s2, right? So that means 8 electrons you are getting from iron center, 2 irons you have, and you have 9 carbonyl. So 16 plus 18, which is also equal to 34. So again what, 36 minus 34 by 2, so you will get again 1. So you will have one iron iron bond, right? One iron iron bond will be there. Fine. Okay, now the thing is the structure. Okay, write down the structure, because sometimes in interview they directly ask, write down the structure. Okay, so one iron iron bond will be there. Now see how many carbonyls you have. 9 carbonyls you have. So first of all give 3 carbonyl to this iron center. Okay, check how I am doing. 3 carbonyl to the other iron center. Okay, 3 carbonyl to this iron center, 3 carbonyl to the other iron center, and now the rest of the carbonyl will be your bridging carbonyl. So that you have to draw like this. One CO is there, other CO will be there, and the other CO will be there. So in total you have 6 carbonyl as your terminal ligands and 3 carbonyl you are getting in bridging ligand. So this is the structure of your Fe2CO9 structure, sorry, compound. Okay, clear? Any doubt? And if I, okay, this is Fe2CO9, right? Okay, per metal, number of metal bonds per metal. So that time it will be what, 18 minus valence electron is what, 34. So 18 minus 34 by 2. So what you are getting, 18 minus 17, that is also equal to 1. So you can check that number of total number of metal bonds per metal, that is also equal to 1. Okay, when I am giving some example, just find both the values. One is your total number of metal bonds, and the other one is your total number of metal bonds per metal. Okay, try to find out the both the values, and this will be the structure of your Fe2CO9. Very simple. You are getting one metal bond, so first of all make the bond, then give 3 CO to one iron center, 3 CO to the other iron center, and then rest of the CO you just make it in bridging. That's it. Okay, clear? Any doubt?
Sir, how to decide the number of bridging events?
Bridging, that is actually typical, but if I consider, so uh, see, this iron is basically what is the coordination number of iron. So that actually depends on your coordination number. Okay, so this 3 is actually making your sigma bond, so definitely 3 electrons are involving here. If you see how many electrons you have, totally you have 8 electrons in iron center, right? So 3 electrons are involving here, 1 electron is doing sigma bond here. Now the rest of the 4 electron bonds, you cannot say they are involving here, because that time, see this kind of bonding when they are doing, so that means one iron, suppose this iron center is donating 2 electrons to this carbon center, so this bond are basically not your what I can say, these bonds are not basically your covalent bond. This can be coordinate bond also, because carbonyl basically it can donate 2 electrons, so carbonyl will donate one of the metal center, it cannot donate 2 electrons to both the metal center. So when carbonyl is donating 2 electrons to this metal center, so that means the iron center is donating the 2 electrons here to this carbonyl. Similarly here also, if I say that this carbonyl is donating 2 electrons to this metal center, so that means this metal center is donating the electrons to this carbonyl. Okay, like that it is bonding is happening. Okay, so that actually needs separate like separate discussion it will be. Okay,
Okay, sir.
fine. Basically they are arranging the electrons like this, because these are your sigma bonds, so there you cannot do anything. 4 electrons is fine, 2 electrons it is donating to here, 2 electrons it is coming from this carbonyl, and the rest of the 2 electrons it will go to there, and this carbonyl will donate to this metal center. Like that the bonding is actually happening. Okay, overall bonding. Fine, clear.
Yes, sir.
Okay, now next, suppose you have Fe3CO whole 12. So find out the total number of metal metal bonds. So what you are getting? How many metal atoms are present here? 3, right? So the n value will be 3. So 18 into 3 minus valence electron. So valence electrons means what? 3 into 8 plus what? 2 into 12. So 24 plus 24, it is becoming what? 48. So 18 into 3 minus 48 divided by 2. So what we are getting? 3. So that means you have, in general you have 3 metal metal bonds. Total number of metal metal bonds will be 3. Now the next thing, per metal atom. Find out per metal atom. Per metal atom, so it will be what? 18 minus valence electron 48 divided by n value, right? Okay, what I have written here, sorry, this will be your valence electron divided by n, n value. How many metals are present there, that will be yeah, sorry, I have make it wrong. Yeah, 18 minus valence electron divided by n. Okay, it will be n value. Okay, so what I am getting here, 48. What is the n value here? 3 metal is present, so it will be 48 minus 3. So what I am getting, 18 minus 16 is equal to 2. So that means per metal you have 2 bonds, and in general you have, in total you have 3 bonds. 3 metal metal bonds are present there. So you have to draw the structure like this: one iron center, one iron center, one iron center, so 1 2 3. In general, in total you have 3 metal bonds, but if you see per metal you have 2 bonds, so that is the structure. Now you have to arrange CO whole 12, right? CO whole 12, so that is basically what. So again it is very simple. Give 3 terminal CO to this iron center, okay, 3 terminal CO to this iron center, 3 terminal CO to this iron center. So how many done? 9 already done, right? 3 left. So for those 3 you have to show in bridging, okay, for those 3 you have to show in bridging. Okay, so this is the overall structure of your Fe3CO whole 12 compound. Okay, these few compounds, you actually need to know the structure, because sometimes they directly ask, okay, write down the structure, then they will ask how many valence electrons you are getting here, okay, is it following 18 electron rule or not, they directly ask, okay. Okay, or how many bridging molecules are there, bridging ligands are there, that also they can ask. Okay, so you need to know this some these are the common things, okay, this Fe2 CO9, Fe3 CO12, even with cobalt also we have some examples, CO3 CO12, okay. So the structure will be basically like same only, okay, but you have to say it properly. Sir, we have that much terminal bonds, that much bridging bonds, okay, that they will ask. And one thing they also ask, that IR stretching frequency value, okay, because they just correlate with the spectroscopy, okay. So basically they asked this question to me in Isaac Tirupati, that first of all they give me one compound, they did not give me iron compound, they have given me cobalt compound. Then after drawing that, they are asking how many terminal bonds and bridging bonds, okay, then they directly go to spectroscopy, okay, tell me like which CO will come in which region, okay. So that you have to say. So basically we have not done still this spectroscopy topic, but I am showing you saying you see when you have some terminal bond, so suppose it is showing, suppose you are showing is 1600 centimeter inverse, that value it is showing. Now if you see, when for the bridging ligand, bridging ligand, it is actually attached to both the metal centers, so that means the back bonding will be more here, okay, that we will do later. Back bonding will be more here and the value will decrease for this bridging actually, okay. So that will come around your 14,000 centimeter inverse, that they can ask, okay, because anything they are asking, they will try to correlate with your spectroscopy topic, okay. That's why organic spectroscopy, even your physical spectroscopy, is very important. You need to know the basic things, okay. But for MSc, no need to worry, they will ask simple things, but yeah, for PhD they definitely they will ask, they will correlate with the spectroscopy, okay. Fine, done, understood. Any question from this molecule? Any question?
Sir.
Okay. Another thing, suppose you have CO4 CO12, okay. So how many metals? 18 into 4 minus, so cobalt means what, 3d7 4s2, right? So 4 into 9 plus 2 into 12, so 36 plus 24, how much? 60, right? 60 divided by 2, so 72, so that means you are getting 6. So in total you have 6, and per metal atom it will be 18 minus 60 divided by n value. N value is 4, so that means 18 minus 15 is equal to 3, okay. That is the thing, okay. Tomorrow we will practice few more examples, then we will done with this. Okay, but this find out the number of metal bonds, this is actually important for both. Okay, for IIT jam also, and for your net, I mean for interview point of view also. Okay, they can ask you for MSc candidate also. Okay. Okay, so first of all just try to find out, okay, how to find it out, then it will be easy. Okay, any doubt?
No, sir.
No, right? Fine, so we are done with today. Okay, just revise the notes properly, whatever we are doing in organic chemistry. Basically, for MSc candidates, they will ask questions from each and every topic. Okay, they can ask you from organic, they can ask you from inorganic, they can ask you from physical. And for PhD people, you have to just focus only one topic. Okay, you can just simply say that, sir, I have prepared reaction intermediate, so they will ask from that only. Okay, and don't scare. Okay, don't scare anything you are doing, anything, any interview you are giving, don't scare first of all. Okay, so just prepare for the interview. Okay, I'm saying it to all. I think Isa already got two offer letters from IIT Madras and IIT Gandhinagar. I think she got. She has interview on 22nd. Okay, so all of you should prepare for the interview, because suddenly they will just give a date that this date you have to come. Okay, so it's better to be in preparation mode. Okay, you cannot delay in that. Clear? Fine. Okay.
Yes, sir.
Okay. Bye. Huh? Good night.